Thanks so much. I'm Michael Wexler, professor of medicine and director of the National Jewish Cohen Family Asthma Institute in Denver, Colorado. We're going to discuss the pathophysiology of EGPA, or eosinophilic granulomatosis with polyangiitis, which is such a complex disease in many different perspectives. EGPA, as you know, is a rare immune-mediated disease that can be organ or life-threatening. EGPA is generally characterized by adult onset asthma that's often severe, by eosinophils in the blood and or in the tissue, and a key feature is the presence of vasculitis in small to medium-sized vessels. EGPA is known to affect a variety of different organ systems, including the nose and the sinuses, the nervous system, where patients can have neuropathy, the lungs, where patients can have not just asthma, but also pulmonary infiltrates, the heart, where patients can have myocarditis, pericarditis, and or arrhythmias, kidneys, where patients can have glomerulonephritis, the GI tract, where patients can have abdominal pain and vasculitis of a variety of different organs of the GI tract, and then the skin, where patients often present with rashes. Basically, nearly any organ system can be affected by EGPA. And one of the key features is that there's presence of eosinophils and or vasculitis, tissue infiltration of eosinophils that may cause inflammation of the blood vessels that contribute to the organ damage. The organ involvement and disease presentation can vary between individuals. Some patients can have just sinus issues along with lung issues. Some patients can have cardiac issues or renal issues or GI tract issues. So it can occur in many different patients in many different ways. One of the other interesting things about EGPA is that it can develop in a phasic pattern. Usually the three stages are a prodromal phase that's characterized by asthma, sinusitis and nasal polyps, and some occasional constitutional symptoms. However, over time, this can evolve into the eosinophilic phase, where you can have tissue involvement by eosinophils in the lungs, characterized by pulmonary infiltrates. You can have GI involvement with tissue involvement of eosinophils in the GI tract, and you can have it in other organs, including the heart. Over time, one of the things that can occur is the development of the vasculitic phase, where you can actually have not just eosinophilic tissue infiltration, but you can develop vasculitis and end organ involvement with a significant potential damage to those organs. And that can present with glomerulonephritis, palpable purpura as a manifestation of skin vasculitis, or neuropathy in which the nerves can be damaged due to vasculitis. Almost any organ can have vasculitis in it. And so it's this phasic pattern that one needs to try to recognize early on to try to identify signs and symptoms of EGPA early on when there is just severe asthma and or sinus disease. One should look for blood eosinophilia. One should start evaluating the patient for pulmonary infiltrates and other organ involvement. In terms of the pathophysiology, one of the key primary histologic features of EGPA, as we've discussed, is the presence of medium to small vessel size vasculitis, along with eosinophilic infiltrates in a variety of different tissues, and the presence of granulomas in a perivascular or extravascular pattern. These histologic features really depend on the organ in which they occur and may not present in the same location as I mentioned. In terms of the small to medium-sized vessel vasculitis, usually there will be manifestation of fibrinoid necrosis and damage to the internal elastic lamina. And this can present with purpuric lesions in the skin, pulmonary infiltrates, peripheral neuropathy, or cardiac or GI tract manifestations. The eosinophilic infiltration is another key feature, and this usually manifests as asthma, chronic rhinosinusitis, myocarditis, endocarditis, and or GI tract involvement. And in each of these, if you do a biopsy, you'll see eosinophils infiltrating the organ with potential of releasing their specific eosinophilic mediators. Lastly, there's the presence of granulomas, and this doesn't occur in all patients, but oftentimes you can see an eosinophilic necrotic center with surrounding giant cells. So these are the key features of EGPA pathophysiologically, histologically, the presence of vasculitis, eosinophilic inflammation, and granulomas. Now, the pattern and pathophysiology of EGPA really involves a variety of different pathways. There is both type 2 and non-type 2 inflammatory pathways that are involved. In general, what's believed to occur is that there's some type of stimulus, often an allergic stimulus, that will interact with antigen-presenting cells and activate different T helper cells. These can activate either T helper 2 cells or Th1 cells. And it really depends on the specific stimulus and the specific pathophysiology in a given individual. In terms of the type 2 inflammatory pathways, the T helper cells will evolve into Th2 cells that can then produce the variety of different Th2 cytokines. Interleukin 4 in particular, as well as interleukin 13, can activate B cells that play a role in terms of producing different antibodies. These antibodies, including IgE, IgG4, and ANCA, can interact at a variety of different levels and cause tissue damage. In addition, another key feature that Th2 cells release is interleukin 5. Interleukin 5 is a cytokine that's involved in the activation, proliferation, and maturation of eosinophils through release of a variety of other mediators, including eotaxin 3, that interacts with a variety of different chemokines and causes eosinophils to go from the blood into the tissue. T cells can secrete Th1 and Th2 associated cytokines, and in terms of Th1 and Th17 cells, they can be involved in the release of interleukin 2, interferon gamma, and interleukin 17. These cytokines, amongst others, play a role in terms of tissue damage, as well as granuloma formation and vasculitis, and are often thought to be associated with some type of neutrophilic damage. So in addition to eosinophilic inflammation, there can also be a neutrophilic process that's involved in the granuloma formation and tissue damage. And the local degranulation of all these different mediators, whether it's the eosinophilic mediators, neutrophilic mediators, plays a role in terms of fibrosis of tissue, inflammation tissue, and tissue damage. While we're gaining a better understanding of the pathophysiology of EGPA, we're also starting to learn a little bit about some of the predisposing factors that can result in the development of EGPA in a given individual. For most patients, it's idiopathic, and we don't have a specific cause. However, we're starting to increasingly recognize that there are both genetic and environmental factors that can predispose an individual to EGPA. For instance, there are variants of a variety of different genes, including TSLP, BCL2L11, CDK6, and HLA-DQ, that have been found to be risk factors for EGPA in genome-wide association studies. In addition, there have been genetic variants that have been associated with EGPA subgroups based on ANCA status. For instance, patients who are anti-neutrophil cytoplasmic antibody positive with myeloperoxidase have been associated with genetic variants in the HLA-DQ gene. And ANCA-negative patients have been associated with the IRF1, IL5, and GPA33 genes. In addition to the genetic variants that can predispose an individual to EGPA, there are also a variety of different environmental factors that have been found to be risk factors, but with no definitive link. Increased exposure to UV radiation, heavy metal exposure, smoking history, amongst others, as well as potential for low vitamin D levels, have been associated with as risk factors of EGPA.
Mike, thank you very much. That was a very clear presentation. I was really struck by, how complex a disease it is. Type 1, type 2 immunity, genetic biomarkers, different phases of the disease. Do we have an understanding of what it is that drives it, or how one organ is affected or another organ?
Yeah, the complexity of this disease is really poses a big challenge to clinicians and to investigators. I don't think we have a great sense of why an individual will get EGPA. I don't think we have a great sense of why specific organs are homed in by eosinophils and can cause tissue damage. Why do some people get it in the skin and other people get it in the nerves and other people get it in the heart? I think we're still trying to understand all of that. That being said, I do think it's important to try to get as much information as possible because it can help guide some treatment decisions based on whether or not there's a predominance of eosinophilic inflammation, antibody-mediated inflammation, or non-type 2 mediated inflammation. And so as we're trying to understand the risk factors, as we're learning more and more about these patients, again, it's really important to try to get as much information as possible about these patients.
The clinical path can be very varied. You highlighted how there's often a prodromal phase, and that can be quite long before it changes its pattern. Do we know what switches it to an eosinophilic or a vasculitic pattern?
No, unfortunately, again, it's one of the other areas that's under active investigation. We're trying to understand what turns someone's immune system on so that all of a sudden they start producing eosinophils, all of a sudden they start developing vasculitis. Is there a genetic predisposition that has an environmental hit? Is there a specific allergen? Are there infectious etiologies that can predispose individuals, that can trigger this switch to a much more complex pathophysiological phenomenon where people just have asthma and sinus disease, and then all of a sudden, usually in their 40s and 50s, they may develop this vasculitis, the eosinophilic tissue infiltration.
And you're talking about the eosinophilic tissue inflammation. Is the organ damage that arises related to eosinophil activation products, such as the basic proteins, which can be tissue damaging? Or is it related to eosinophil activation leading to small vessel, medium vessel thrombosis and ischemic damage?
I think it's a combination. I think it's a combination of all of those factors. Certainly, when eosinophils get into the tissue and get activated, they can release their mediators, major basic protein, eosinophilic cation protein, eosinophil-derived neurotoxin, all of which can cause localized tissue damage. But on top of that, you can cause eosinophilic inflammation at the blood vessel wall. There can be recruitment of these anti-neutrophil cytoplasmic antibodies that can cause recruitment of other inflammatory cells. And those can also result in thrombi in the blood vessels as well that can cause the tissue damage. So there's a lot of different features. And that does, I didn't even mention the neutrophilic inflammation that can occur and the granulomas that can occur as well.
There's obviously still quite a bit of sorting out to do for us to fully understand whether this is one disease or a mixture of diseases.
Yeah, I think that's one of the challenges that we have here. The heterogeneity of the pathophysiology, the heterogeneity of the presentation, the heterogeneity of the course. It's not just simply, one specific pathway that's easily recognizable. And that's why we're here today. It's to try to educate people about all the different ways that EGPA can present, all the different ways that EGPA can cause tissue damage.
Oh, well, thank you very much indeed. Thank you.
Thank you.